Today we are going to be talking about a very important term in data science, and this term is something many data scientists or new data scientists have actually overlooked. That is the question of multicollinearity. So we are talking about multicollinearity. We are talking about a situation whereby we are trying to create a model that relates some variable to another variable y. But in this case, we have several xi, xj, xk. So let's say we have several independent variables. We are trying to have a multivariate linear relationship between this variable and the independent variable. So this is L. All right. So multicollinearity is the occurrence in multivariate linear regression where a linear relationship exists between two or more independent variables. As such, the estimation of the regression coefficient becomes unreliable and sometimes it becomes hard to perform an analysis. So before I highlight how to test for multicollinearity, let me outline some of the challenges of multicollinearity. So the first one, let me call it challenges. Challenges. And this is something you should know because in a quiz you can be asked what is a problem, why is multicollinearity a drawback or a problem. So now so we can say effects of one independent variable on the other cannot be separated. Okay, so in this case, we're trying to model xijk related to yl. What you find out that xi is having some kind of correlation with xj, and that makes it difficult now to model xi correlating with y. So multicollinearity is a relationship between the independent variables in a multivariate linear regression. So another problem of multicollinearity is that the independent variables IVs assume each other's role. So in this case, xi may actually assume the role of xj, xk may assume the role of xi, and so on. So that is a whole lot of problem in regression. Coefficients estimated will now become unreliable. Coefficient estimates may be unreliable. So, sorry, I'll do this. Unreliable, and then sometimes performing analysis may be very difficult. Analysis can become difficult or even impossible. So these are the problems of multicollinearity. So how do you now test multicollinearity? Granted, in some multivariate linear regression, you can have collinearity existing, but it might be insignificant. So there is something called variation inflation factor that you need to keep under your belt. So this is called variation inflation factor. Okay, do this. Variation inflation factor. So keep it under your belt because that shows that you're actually very good in data science. Variation inflation factor. So this term here is a term used to test for multicollinearity in a multivariate regression. So it shows the actual variation of estimated coefficient of the jth variable how many times greater than the variance could be without collinearity. So more like it's trying to tell you the variation that is caused by collinearity of xi. So it's calculated in this way: VIF is equal to 1 minus R 1 over 1 minus Ri squared. Of course, you know R squared is coefficient of determination in regression. Then Rj is the coefficient of multiple correlation on the j variable, right? So for me, I think in this case we are talking about I, right? So we have to also, it helps you to find out what is the correlation between xi, the correlation caused by xi on other variables. So now I'm not going to actually write the formula or do the analysis for now. I just want you to understand the concept, be able to explain it, and use minimal notations to represent it. So basically, I'm going to stop here. And in the next class, we now discuss another concept that is really very important, and that is the concept of heteroscedasticity. So I'd like to also remind you to subscribe to my channel, and we see in the next lesson, in the next question.